Today we're going to discuss how do we read a graph. Okay. In this graph, you'll see there's some information given to us. What does it tell us? Well, if you remember from the other day, we said that on the x-axis, the horizontal axis, we put down the independent or manipulated or controlled variable, all right? This is the independent variable. On the y-axis, or the vertical axis, we put the dependent variable. Meaning, the dependent variable is the one we measure. We measure the effects of the independent variable on the dependent variable. Okay, so let's see what information this graph gives us. If we look, there's little hash marks here going up, and there's little hash marks here going across. Okay, so those hash marks have values. Going up, you have 1, 2, 3, 4 hash marks before you get to the 10 meter per second hash mark. So this is going to be 2, 4, 6, 8. And what you should notice is the value of each box follows an appropriate scale. So each box is worth 2 meters per second, going all the way up the entire y-axis. You cannot change it once you establish the value of each box. If you start at 0 and the next one's 2, they all have to be worth 2 meters per second. And the same thing holds true going across. But here, you're talking about an entire second. So this is a decimal point, 0.2 seconds, 0.4, 0.6, 0.8, 1.0. So the scale going across on time is 0.2 seconds for every small box, and for every larger box, it's 1 second going across. Okay? Now, how do we read this? What does this tell us? This graph tells us that at the 1 second mark, you're going between 2 and 4 meters per second. So you're going about 3 meters per second at the 1 second mark. At the 2 meter mark, at the 2 second mark, you follow it across, you look at the left, try and go straight as possible. You're going about 7 meters per second. At the 3 second mark, you're going 12 meters per second. At the 4 second mark, you're going 18 meters per second. At the 5 second mark, you're going 30 meters per second. And at the 6 second mark, you're going about 45 meters per second. So at each point across the x-axis, you can find the value looking up and going across on the y-axis. Okay? That's how we read a graph. Let's look at this graph. This graph is a little bit more confusing because it has 2 lines on the same graph. But if you look, it's really saying the same thing. At 8 a.m., the outdoor temperature at the family reunion was a little bit, probably somewhere around, if this is 65 degrees, this mark is 67.5, somewhere around 68 degrees. Okay? So this graph is going up in temperature by 2.5 degrees for every line. And going across, we're measuring every hour. So at the same time, indoors, it was about 72 degrees. Okay? So you go up to the point, you go across, you figure out where you are. So this is 77.5. This is 72.5, this line. 82.5. Okay, so you just got to find out. If you choose, say, hey, at 11 o'clock, what was the temperature outside compared to inside at the family reunion? So you'd say, all right, at 11 a.m., you go up to that point, then you go across to the left, and you find that's right on the line there. It was 85 degrees outside at 11 a.m. Inside, though, it was much cooler. It was slightly below the 75-degree mark. So somewhere around 73, 74 degrees. Okay? So that's how we would read a line graph. And if you have any questions, write them down. Come on in. Ask us about it, and we'll be happy to explain it, okay?